Hello, everybody. My name is Shreya Dubey. I'm the CEO and co-founder at Via Separations. Delighted to be here. We spun out of MIT in 2017 and have since scaled up the technology coming out of the material science lab, a material science department with Jeff Grossman by 100 million times, which is a preview for what we're going to talk about after this first presentation. Many people don't know this, but the emissions associated with separating different chemical compounds from one another are larger in the US than that of cement, lime, iron, and steel combined. And that's because we process raw materials largely the same way we have for over 100 years, which is boiling off all the water to get to pasta at the bottom of a pot instead of pouring it through a strainer, which is inherently more modular, requires 90% less energy on a thermodynamic basis, and is a fully electrifiable process. More importantly, we spend hundreds of billions of dollars on energy that we don't need to be spending, and that is cost for industrial commodity producers. And so the way we approach this market is by systematically replacing those evaporators and distillation columns across a broad swath of industries. So shown here is our serviceable addressable market built from a bottom-up perspective. These are the applications where the technology fits, where the economics make sense, where the customer has shown interest, where we have the data to show that there's a market there. And I'm going to share a little bit about our story to get here, but also where we're headed from there. So we deliver, so our customers, industrial manufacturers, they have two top priorities: safety and reliability. Neither of those is climate. None of those say carbon or green. And that's very important. We deliver operational savings. We deliver cost savings. We deliver flexibility to industrial customers while simultaneously decarbonizing their operations, giving them lower CapEx, OpEx, modular capacity for expansion, and lower costs from an energy or chemical or feedstock perspective. This delivery of no green premium allows us to access commodities like cardboard boxes from Amazon or pharmaceutical products without increasing the cost associated with it. Our core intellectual property is coming from MIT is the membrane material, so that pasta strainer material. It's a materials innovation. We have scaled up with manufacturing partners, and we have delivered at scale. We're leading this transition for the chemical sector. It's already happened in the water industry. So prior to about 1990, the majority of water purification was done using heat. Again, boiling off that water, collecting it, distillation, multi-effect evaporators. But the industry has transitioned almost entirely over to filtration, so much so that when people say membranes, they say, what about water? And if I had a nickel for every time somebody said, oh, you do membranes? Well, what about water? Then I wouldn't be here fundraising. But I am. We did not invent the thermodynamics. We did not invent the manufacturing process, but we put together a couple of different pieces of the puzzle to deliver a product that hasn't been delivered before. We deliver these modular Lego blocks, the membrane housings, the pumps, the pipes that can be configured to fit a customer's physical space. It can be configured to fit their physical assets, but really just moving those pieces around in order to give them the biggest bang for their buck. And we're doing this today at scale. That's a real photo. It's a little blurry, but that's a real photo. This is not a pilot. This is a real paying customer. International Paper is one of North America's largest pulp and paper producers. This particular facility makes the precursor that goes into diaper fluff and toilet paper, in case you were wondering. But other paper manufacturers make things like compostable food packaging or cardboard boxes, not just consumer products, but also the ones in warehouses, and so on and so forth. A really kind of foundational industry. We're in various FEL processes, design processes for about the next six projects. And we only need to deliver on 3 of those in order to achieve positive EBITDA. So we're running off to the races with this project, which is in Grand Prairie, Alberta. We've been operating for now 11 and a half months, which will prove in 2 weeks the 12-month cycle that underpins the unit economics for this and all the other future products. So it's very exciting for our team who worked really hard to deliver this project on time, kind of on budget, but working, which is the most important part. Importantly, our customers have very boring things to say about this, which is it works. And it works, it gives us the value that we want, and we would do this again. So don't have to take my word for working. We have a couple of different ways we can look at this. Uptime is an important metric. Again, safety and reliability being number one and number two priority. 90% is a target. That's what we're contracted. Over the course of the first 6 months, we figured out a few things as we learned what operating a system in, for example, minus 40 degrees is, which is where Fahrenheit and Celsius overlap. So it doesn't matter which unit you're using. It turns out it cools everything down, and sometimes that creates some problems. We solved it, we figured it out, and we have stabilized out at an over 95% uptime on average. And then I mentioned the delivering on unit economics. So in order to kind of deliver our customers unit economics, we have to deliver at this black line in terms of throughput. We are well above that for most of the part. We played around trying to see what we could do in the middle, but have returned back to this. When this tanks is when the membranes need to be replaced. And so we're expecting to see that. We were expecting to see that right about now. We haven't yet seen that. So this will be really important for our unit economics going forward. So now we're expanding into adjacent markets, namely the refining industry and chemical production. A couple of ones that I'll talk about that I'm personally very excited about right now is number one, sour water stripping, which is a very important process in a refinery for the refinery's ability to process higher sulfur crudes, which is a lower cost feedstock. So refinery unit economics are defined on what you're selling and what you're buying and what you're doing in the middle. And if you can process cheaper feedstock and deliver the same end product, then you have a larger spread there. This is impactful because you can add capacity, so you reduce downtime or slowdown events for the customer. You can decrease their feedstock. And because we aren't bound to the chemical engineering scaling laws of evaporators and distillation columns, we can add capacity modularly. So we can say, okay, well, this year we'll do 10%. 3 years down the road, we might add another 20% and continue to sell to a repeat customer when they're looking for capacity expansion. Another one I'm really excited about is sulfuric acid concentration and purification. So it's a catalyst that's used both in refining and then also in specialty chemicals. And that's a process that can only be done centralized because, again, you need those economies of scales for the evaporator and distillation columns. So sulfuric acid, 98% sulfuric acid is being shipped by truck on the same highways that we all drive on to get from a refinery across state lines to a place where it can be processed. We can decentralize those operations, put them back onto the sites, or at least co-located with refineries, and deliver the same product, the same commodity, using a lot less energy, a lot less transport, and a lot less hazardous material transportation. And then finally, we are working on a feedstock of fertilizer production on a very large capacity expansion for fertilizer production in phosphoric acid. And that is something that's just up and coming, kind of breaking news, and we're super excited about it. So today, I'm circling with our technology risk retired with an oil and gas strategic major in our current round, and with all the progress that we've made to date. I'm circling the last $10 million of our B2 raise, but I'm always happy to talk about your favorite refining or chemical production process, whether or not we can help it. Probably we can. Anywhere there's an evaporator or distillation column, I'm eager to talk about it. So thank you very much.